Okay, welcome everyone to the class, and I am very happy to have everyone again in today's class. So, as usual, I would start the class by asking the usual question I asked. If there's any question from previous class, and if there's none, we basically would just proceed with today's class. So if I may ask, is there any question from previous class? Okay. So with a lack of question, that means it's time for me to instead ask question. So is there anyone who is willing to raise his hand to summarize everything we discussed from the previous class? That's yesterday's class. Is there anyone that can summarize everything we've discussed from previous class? Should I call names? Okay. So we have someone, we have Silvanos. Let's hear from you. Can you give us summary from what we've discussed from yesterday's class?
Thank you. I'll give you a summary of what I understand from yesterday's class. So basically, you talked about how how blocks are formed and how a chain is formed and what is in a block. So
Thank you.
basically, you're saying uh, the original block, it has it's called a Genesis block. Genesis block, it has zeros when it's hash. So when you generate some information, any kind of information into a block, it forms a new hash, which is then added to a new block as previous hash. And each time any alterations has been made in those blocks, the hashes and also the nouns changes their values.
Excellent. Thank you so much. That means you really had your heart in yesterday's class. Thank you very much, Silvanos. That's really impressive. You really gave your answer, in fact, based on the graphical illustration I used on how a new block is formed and how the blocks join together to form block of chains and how it then becomes decentralized and how all of them are connected to each other. So thank you very much, Silvanos, for that answer. Is there anyone else that's willing to also share what they've learned? We just take one more person and then we start today's lecture. Is there anyone who can still remember? Okay. Shalka.
Yes, good evening, everyone. I'm Chaliga from Tanzania.
Great.
Yeah, we also discussed the benefit of blockchain technology. We have learned that in blockchain, we gain the transparency on transactions compared to the central banking transaction system, where only the central bank or the bank is only having the access to your balance on your account. And also we discussed about the security on cryptocurrency technology, which protect data integrity. So no one can change the data in between, because once you change the data, we have seen from the blockchain table. So if you change the one block, it will impact the other blocks. So it will never go anywhere, because this system is built on the decentralized. Excellent. The other thing we have discussed about efficiency, that the system is automated transaction. It go through to the receiver. There is no intermediary system which processing the transaction. We also I've seen that there is traceability, so you can trace the record from the original to the final. So if someone steal, you can see on the ledger that this transaction was initiated on that time from point A to point B.
Thank you so
So
Thank you.
that's all.
You've literally did a very great job. I'm so impressed hearing this answer. Thank you so much, Shaliga and Silvanos. You guys have really made me happy because you literally gave me what I gave you yesterday. And it's so impressive to see that, yes, impact have been made. So I'm very happy to proceed with today's class. And yes, it's a great one to really hear this from you guys. Thank you so much. Thank you so much. So um, we started by asking if there's any question, and then we moved on to talking about what have been taught from previous class. And Silvanos and Chaliga literally gave the highlight of everything we discussed from the previous class. So thank you so much. Today, we'll be starting from the challenges and the limitation of blockchain. Now, we've been talking about beautiful things about the blockchain. It's transparent, it has security, it has efficiency, the traceability. We can see all of these are beautiful things about the blockchain. But are there limitations to the blockchain? Well, yes, there are. The first limitation we'll be talking about today is the scalability. What does scalability of the blockchain involve? This involves the difficulty to handle so many transactions at a time. And it is actually something that makes sense for the blockchain to have this problem. Why? This is because every transaction has to be replicated on all the different nodes. So all the different nodes literally have to have this transaction. That's one. Another thing is all of these transactions also have to be, verified before they are added to the block. So for this very reason, the transactions are not so fast. Now, I'll give example of a normal banking system. I would use Visa as an example. Visa makes about 100,000 transactions in a second. So we can compare Visa making about 100,000 transactions, above 100,000 transactions in a second, compared to a blockchain that can handle probably 10 to 20 transactions in a second. So now we can understand that now if you are trying to build a very huge infrastructure where so many people have to do so many things simultaneously, then we will need something that is very fast. Then that is where that scalability issue comes in. So it's a limitation for the blockchain. Now, that limitation has now been solved by different chains because in today's world, we hear about layer 2 chains that are solving the scalability issue by using cryptography and zero knowledge proof to, create a blockchain that the proofs and the transaction can then be bundled together. It can be verified fast on the layer 2 chain and bundled and sent to the layer 1 blockchain. Yes, there are different blockchains that does that. But at the end of the day, it still boils down to how secure are these blockchains, because different blockchains use different methods to do this. Some use what we call optimistic rollup, others use zero knowledge proof, and we just keep hearing different blockchains trying to solve this scalability issue. But that is one of the limitations and challenges of the blockchain. Another one is energy consumption. Now, when we talk about energy consumption, you start casting your mind back to when I was explaining proof of work, and I was explaining how much computation proof of work needs for the system. Now, you start talking about Bitcoin, for example. Now, before transaction are being added to the block, it has to be mined, and these miners literally have to use so much computation power. And this computation power means they are using electricity, and as electricity, around different parts of the world, it's quite consuming and it's quite expensive for this. And so, although other blockchains that don't, take in or make use of proof of work for their own consensus mechanism, for example, Ethereum that uses proof of stake for their consensus mechanism, you still have to, pay that certain amount of money that you need to stake, to participate in the network. And how many people can afford 36 Ether, if I'm correct? That's the minimum amount for you to, participate in the proof of stake mechanism for you to validate a block. How many people can afford that? So that's more like also a challenge and limitation for blockchains that are now, consuming so much computational power, like the blockchains that use proof of work. So in a nutshell, that is literally just a challenge. Another challenge is regulatory uncertainty. This means that there's no clear regulation in any jurisdiction. So that means anybody that steals money, that is, you could steal a person's private key, or some people have access to your private computers and they are able to use some hacking tools like keyloggers and other things to literally gain access to your system. And then using all of this, they create something like a payload and backdoor, and they have access to your wallet or they have access to your private key, and then they move your funds. In a normal system like a bank, you can go to your bank and report and say, hey, my money have been stolen, and easily the bank would definitely trace who moved your money, and they can see the name of the person's account it was moved to and how the money moved from this to this and all of that. You can there's an authority, there's a jurisdiction that can regulate things and tell you, okay, you are laundering money, and the money you are laundering, you have to go through a bank, and you can do all of this easily on the blockchain. And so this can serve as a challenge and limitation because some people, some bad actors see this as an opportunity to exploit the benefits of the blockchain. So if they can easily launder the money through the blockchain and they try to go scot-free. They steal people's private key, try to get that. All of these are limitations of blockchain. Another one is adoption. Now, compared to the traditional institutes, you need to have some certain amount of knowledge for you to operate on the blockchain. So it's not easy to easily break in to start using the blockchain technology. So yes, that's actually a challenge. Unlike the bank, the moment you go to a bank, they just give you your account number, they tell you to fill a form, and they give you your account number and all of those. It's easier, but for someone to sit you down and start explaining what your private key is, what your public address is, how you can convert your tokens, how you can deploy, how you can interact with this decentralized application on this chain, how to navigate between this chain and this chain, that could also pose as a challenge, as it needs a level of technical expertise for you to grasp and understand and adopt the blockchain. So these are few examples of challenges and limitations when it comes to the use of blockchain. Okay. Someone has a question, you can unmute.
Yes, I would like to understand on the point of adoption and regulation. Is Africa having a good race in adoption this blockchain technology? And let's say also another question: does these applications allow people to key in their KYC. So once someone steal, maybe you can find out who is that.
Great question. Great question. Now, that is one thing the blockchain has been trying as a whole. The blockchain ecosystem has been trying as a whole to try to regulate. And for this reason, you start hearing of different things like DAOs, decentralized autonomous organizations. They try to come together to create a body that regulates certain rules and all of that. But at the end of the day, if you have to be very honest, one of the main characteristics of the blockchain is that it is decentralized. And when something is decentralized, it means the ability to fold it into a centralized entity becomes difficult. Now, for any blockchain that now requires that you now start putting your KYC and your personal details, that means that personal details, who exactly is it going to? Is the KYC you are doing going to a central authority? Or now, who then is verifying it? Remember, we are calling it decentralized. Now, all of this KYC that has to do with blockchain, when you start seeing something like that, it starts coming to your mind to talk about something like a centralized exchange. And a centralized exchange is a completely different thing from the blockchain. Now, the centralized exchange make use of the blockchain, but they try to control their users. So most of what they do there, they also use back-end technologies there. So you don't completely have access. That's why centralized exchange would not give you your private key. Rather, you see what they show to you in your dashboard because you don't have complete access or control of the money. Although it's your money, but it's a centralized exchange, you have access, and that's why you go through all the KYC procedures and all of that for it. But as long as it's the main blockchain itself, it is decentralized. And why there are so many people trying to regulate different things, it's very difficult to regulate it. I don't know if that makes sense to you, Shaliga.
Absolutely. Thank you.
Okay, great. Great. So we'll be moving on to use case of the blockchain technology. One of the popular use cases of the blockchain technology is cryptocurrencies. Now, many people want to think that blockchain and cryptocurrencies are tightly closed and it's the same thing. No, it's not. Cryptocurrencies are applications on top of the blockchains. The blockchain itself is the fundamental, while cryptocurrencies are just applications, one of the applications of the blockchain. And yeah, it's easy. For people that work remotely, that has been working remotely for a very long time before now, you always know that it is very difficult for you to get your salaries. When you get your salaries, probably you are paid in a different currency compared to your local currency. You then have to go through certain bank authorities. And by the time the money being paid to you is converted to your currency, so many charges would have been done to it. So in this case, it becomes a problem. It becomes a problem for those that are working remotely. And this is a very good use case whereby you are being paid in cryptocurrencies, in that you are paid USDT, USDC, or any stable token of your choice. And these stable tokens are just sent directly to your wallet, and you do not need any third party to try to help you convert it from whatever foreign currency it is to your local currency. So that is a very good use case of the blockchain technology. And in fact, that's probably the most popular use case of the blockchain technology. Another thing is the supply chain management. Now, all of these things we are talking about as use case of the blockchain technology, I want you to have it as at the back of your mind, because we're also going to be having competitions. We are going to be having competitions whereby we have what we call hackathon before the end of this semester, And you definitely would have to pick yourself as groups to, think of ideas, a use case that you can build on the Stellar blockchain. And, these are literally some ideas, use case of the blockchain. So the only thing that comes to your mind is not just going to be a token for the cryptocurrency. Now, another one is supply chain management, enhancing transparency and traceability of goods. Imagine you build an application whereby on the application, so amount of goods are being recorded that are, coming into the company, and these particular goods, as they are moving from one place to another, it is also recorded there. Everybody is saying that, okay, this goods is at this point at this particular time, and when it's leaving from here, it's also going to this particular place. So that's another use of the blockchain. Everybody can see that, okay, nobody is stealing your stuff. It's moving from here to here, and it is here at this particular time. Transparency. Another one is healthcare. Imagine a situation whereby you travel from one part of the world to another part of the world, and you don't have to tell the doctor your medical history. And all the doctor has to do is just to check the blockchain, and it's going to get your data, your medical history. How interesting would that be? It would be so easy to store patient's record and ensure that the record is available to them at different locations at different time. Although there is a problem in that. And that's exactly why people are trying to look for opportunity to build something called a semi-private blockchain. Because obviously you would not want your own record to be open, your own health record to be open to every single person. So for that reason, you would want a little privacy to it. And so different different groups of people are coming up with different technologies that would also take care of that. Because while it's a benefit, I don't want you to know some of my medical records. So that's one situation. Another thing is finance. In fact, that is one of the beautiful things Stellar is solving cross-border payment and reducing fraud. Why you would tell some people that, okay, I want to send money to this person, and they call themselves money changers, and they eventually scam you. It's easy for you to send payments through the blockchain. And I even made mention of for those that work remotely from a different country and they work in a different country, they stay in a different country and work in a different country. It's easy to use the blockchain for your finance and all of that. Another thing is voting. Imagine everybody is voting, no one is stealing the ballot box, and all you have to do is you vote from your different locations, and everything is seen on the blockchain that, okay, this vote is coming from this individual, it's coming from this individual. It's tamper-proof. No one can change anything from it. This is another application of the blockchain. So when you are thinking of the blockchain, you can think of numerous applications to it. It doesn't always have to be the most basic of things when you think of cryptocurrencies. This should, because this class, you are learning to be a blockchain developer. So your idea on what you can use this technology for should not be reduced to building tokens. It should encompass different aspects of things. You can think of a school record. Imagine having a DApp, a decentralized application that literally gives access to students from different schools. I'm giving you ideas now that you can use for your hackathon, but it's fine. You can build it, and different schools would literally log in, and then when a student is transferring from one school to another school, the new school can literally get access to the student's previous record. And with this, it's easier to move and to transition a student to understand the student's problem and all of that. All of this is easy through the blockchain. So, overview of major blockchain platform. All of this would not be new to you. There are so many blockchains out there now. But what we'll be focusing on in this semester, although everything we have been doing based on the curriculum for now, it's the fundamentals, because before you move on to know the major aspect of what you are doing, you have to understand the fundamentals. Remember, the fundamentals is important. So some of the blockchain platforms you know about: Bitcoin, Ethereum, Stellar, obviously, Hyperledger, Cardano. So these are some of the blockchains, and there are so many right now. We have Biz, Arbitrum, Optimism, Scroll, Hyperledger, so many blockchain out there right now. Although these different blockchains have different technologies to write their smart contracts with. So the Bitcoin overview. Introduction: we know that Bitcoin is a decentralized digital currency that operates without a central authority. Yes. What are the key features? It makes use of proof of work consensus mechanism. It has a limited supply of 21 million Bitcoins. Transactions are pseudonymous and secure. Use case: digital payments, store of value, remittances. Yes. That's an overview of the Bitcoin. So we will not be taking so much. We'll be taking just three: Bitcoin, Ethereum, and Stellar. Then at the end of the day, we are going to focus on just Stellar. The next one we'll be talking about is Ethereum. Now, before I proceed, at this particular point, I want to take a pause and ask, is there any question based on what I've explained up until this point? So use the raise hand button if there's any question, or I can get the thumbs up to continue that yes, you are truly understanding and everyone is following up with me. Okay, I think there's a question. You can unmute and speak.
Hi, Mr. Ayo. How are you?
Hi.
Good. Listen, it's pretty interesting what you actually are letting us, the telling us about our lecture. So I see there's a lot of things that you mentioned in what the blockchain system does, right? So is it just those platforms where it's just the voting, the how? Does it also spread even wider onto other aspects and other elements, or is it just only what you just um, um, had on the presentation?
Oh no. Remember, I also made mention of schooling records.
Yeah.
That's on the slide. These are just example use cases of what you can do with the blockchain technology. Remember, I explained that the blockchain is a world computer, is a quasi-Turing computer. So is there a limit to what you can do with your computer? Almost no. As long as you can think of the idea, you sit down and you're like, okay, I have a food business and I want to build an application that would control all of the different restaurants from different locations in my environment. And I want to ensure I have all the data of my staffs. You can literally think of anything and build it on the blockchain. That is because the blockchain have the execution layer where you can deploy what we call smart contracts. Now, at the course of this lecture, when we move on to Stellar in depth, you would start by learning about what we call the Soroban smart contract. So the Soroban smart contract is the official smart contract deployed on the Stellar chain for you to build your decentralized application. So it's literally a framework of Rust. Is there anyone, can you raise your hand if you are familiar with the Rust programming language here? Is there anyone familiar with the Rust programming language here? Is there no hand? Okay, great. So what we are going to learn is, we are going to start by learning about the Rust programming language. So the curriculum spans through understanding the fundamental of blockchain, then moving to understanding Stellar blockchain, the fundamentals of Stellar blockchain, then moving to learning Rust. So you basically be writing practical Rust. I'll be teaching you Rust in the course of this semester. And you would also move from learning Rust to learning Soroban smart contract. And from Soroban smart contract, you would start writing your own application. You just think of anything, and that's what the hackathon will be all about. Think of any idea and implement it. If it's a beautiful idea, then you get to win the prize. Although it's not just stopping there. If your idea is so good, you can use it to apply for SCF, and you stand a chance to win about $250,000 for grants coming from the Stellar Foundation. So if you take this serious and you are literally able to, focus on until the end, you can build anything, and you can literally, expand from there. So does that answer your question? Before I come to you, Mark Paul. Okay, great. Yeah, you can unmute and speak. Mark Paul, your answer.
No, sorry. This was from the time when you asked for if there's any developers, and I thought it was just like a one-time thing. My bad.
Okay, great. Okay. So we'll be moving on from there. Ethereum overview. We've spoken about Ethereum. You notice that some of the things I'm talking about, it feels like it's a little repeated. I've always said it, repetition is the father of learning. When you repeat, it sticks. And when it sticks, you remember. So don't get tired of hearing certain concepts, as you might hear it the first time, you're not so used to it, but hearing it the second time, the third time, the fourth time, then it gets sticked to you. So overview of the Ethereum. Ethereum is a decentralized platform that enables developers to build and deploy smart contracts and dApp. So as a blockchain, in blockchain now, you can choose to not be a blockchain developer. You can choose to be a blockchain engineer. Now, there's a difference between it. You can choose to work on the core of the blockchain, that is the infrastructure layer. Then you can choose to work on the application layer. So that is, you can choose to work on smart contracts, write smart contract applications and deploy it on the chain. Or you can choose to work as a blockchain engineer that works with the infrastructures of blockchain. At that particular time, you now learn how to implement consensus, how to implement a gossiping layer, how to implement distributed systems. All of this is part of what you learn when you are becoming a blockchain engineer. That is the very infrastructure level. But that is not part of what this class will be all about. The class will just focus on smart contract engineers, smart contracts developers that will be writing the smart contract and deploying it on top of the chain. Key features, we said it uses a quasi-Turing complete programming language. Yes, that's Solidity. And also some other, Ethereum also supports Viper apart from Solidity. Then it supports the creation of custom tokens, that's the ERC20 NFTs, the ERC721, and also its transition from proof of work to proof of stake, Ethereum 2.0. I made mention of that. Use cases, decentralized finance. I spoke of automated market makers. There are more than automated market makers, but that's one of the popular ones. There are other ones like proactive market maker. That one was created by Dodo Finance. Yes. So it's also a DeFi product. Another is NFTs. I'm sure you must have heard of NFTs. Then DAOs. I made mention of DAOs when I was talking about some group of people coming together to create an organization that includes voting systems and regulations. So these are use cases on the Ethereum chain. Stellar overview. Stellar is also a blockchain platform that literally allows you to create smart contracts too. But Stellar does not allow the deployment of Solidity smart contracts. So in the course of this class, you will not be learning Solidity. Instead, you'll be learning Soroban. It allows you to deploy your Soroban smart contract on the chain. It also facilitates cross-border payments and asset transfers. This is one of the great things for Stellar. It uses the Stellar Consensus Protocol for fast and low-cost transactions, and it's focused on financial inclusion and connecting financial institutions. Also, it supports issuance of custom tokens. Now, notice that all of these key features I'm talking about, all of them are just few of the things you can do. There are so many things you can do as long as you are writing a smart contract. As long as you are writing a smart contract, there's a whole lot of things you can do. So are we comparing the blockchain platforms? Bitcoin focuses on being a digital currency and store of value. Ethereum focuses on providing a platform for decentralized applications and smart contracts. Then Ethereum is versatile with a wide range of applications. Stellar specializes in cross-border payment and financial services, but it also allows for different range of applications too. It allows for that, but it focuses more on cross-border payment, and you can literally build your application that handles cross-border payment using the Stellar SDK. Key concept recap. So this key concept recap, I don't know. I want 4 people to actually explain consensus mechanism, decentralization, transparency, and immutability for me. And I want it to come from the class. So Shalinga have spoken and Silvanus have spoken. I would want someone else to give in detail what this means for every single one of us to benefit from. So is there anyone raising the hand to explain these 4 concepts? Or should I call names? Is there anyone willing to explain any of these concepts? Can everyone hear me? Okay, great. Okay, great. Okay, great. Okay, great. Adi Wolf, you will take consensus mechanism. Olamite will take decentralization. Someone else raised his hand before. Ben, yes, Ben will take transparency, and Silvanus will just help us with immutability. So let's start with Adi, consensus mechanism.
All right. Good evening to everybody in the class, and thank you so much, Ayo, for leading the program. So just taking on consensus mechanism, guys, I'd like, sometimes the easiest way to explain something is by using an example that could be affecting you in daily life, and
Yes.
then like a simple brief of what consensus mechanism means is any method to use to achieve agreement, trust, and security across decentralized computer network, So let's say, for example, I'm in the decentralized finance space, right? And we are in a space where we are trying to build a business that is going to be powering small, medium enterprises to be included in the finance industry, to be able to build businesses and grow their environments and create a sustainable society, right? When you find that there's no agreement at the top levels, especially in, how can I put it, in traditional ways of how finance is being done, it tends to sideline other, and how can I put it? It tends to sideline the other smaller players in the game who want to access finance in order to be sustainable, because we've seen it across the board or internationally that trust is even rare amongst those financial systems that we think we have trust in and that we've based our trust and our money in. So once we have a consensus mechanism that has trust on all levels using decentralized methods, we are able to have an open system in society. I'm not sure if I've put it nice and clear, just also a bit nervous, yeah?
Yeah. I really appreciate you raising your hands and explaining that. That's an excellent application of what the consensus mechanism is. So thank you very much, Adi. And in simple terms, it made clear that consensus mechanism is just a way to create or achieve agreement. So thank you so much, Adi, for that. So we move on to Olamite. We would explain what decentralization is.
Okay. Decentralization actually means that there's no single control, there's no point of control, no single entity or one entity controls the blockchain because it is maintained by multiple participants. And for that reason, it makes it very, very difficult to bridge or to hack into the blockchain network. And that is exactly why they call it decentralization, because the storage point is divided into multiple places using the node. Everyone can run their node. I can have a node, you can have a node, and the more the node is, the more the blockchain becomes stronger and stronger. So yeah, that's it.
Thank you very much, Olamite, for your explanation on decentralization. Yes, a distributed systems that is being accessed by everyone across different locations. Yes, that's one of the concepts for the blockchain. Then, who is the next person that's meant to explain transparency? I think that's Ben, right? Ben? You can unmute and speak, Ben.
Hello, how are you?
Yeah, it's great to hear
How
you.
are you doing? Hello, everybody.
Hello, Ben.
Okay, I'm gonna be speaking transparency, right?
Yes.
Yeah, transparency. It's everybody can see what is happening on the blocks at any time. So you can, like now with the banks, like you explained the other time, we don't really know the transactions. We can't really access the transactions. It's a long process to access those transactions. With blockchain, it is all transparent. Anybody can just go in and have a view and look at those transactions, but there is some information that is limited. You did mention, right? And yeah, that's about it. That's what I think I know so far about transparency in blockchain.
Excellent. Thank you, Ben. I think
Thank you.
Keisha wants to say something on transparency. Okay, the answer has been dropped. Okay, Sunday, you want to add something on transparency? Oh, the answer has been dropped. I think there's a lot of feedback coming from you. Okay, so we don't take so much time on this. Let's hear from Silvanus on immutability then.
Okay, thank you, Ayu. So on immutability, like you said, you give an example of Alice and Bob sending each other money, $100, and that transaction is recorded on the blocks, and it is recorded through a cryptographic link, the previous block and the new block, and distributed across the network. So any attempt to modify it would require any altering sequential blocks and any control of majority of the network, making it tamper proof, and no one has the ability to alter or even delete the information stored on the block.
Excellent answer. Thank you so much. Yes, the inability to alter transactions that has been recorded is one of the features of the blockchain, which is immutability. So thank you so much, Silvanus, and thank you, Adi, Olamite, Ben, and others that raised their hand. So we would continue from here. I really appreciate the fact that everyone was able to bring out what they have learned, and they can literally understand and express themselves through it. Blockchain in action, transaction example. I know by now you must have been tired of hearing Alice and Bob. Well, it's a name you would always get to hear about. So Alice sends 1 Bitcoin to Bob. The transaction is broadcasted to the network. Then the block is added to the blockchain, and then the transaction is confirmed. Miners validate the transaction and add it to a new block. So that is an example of how the first blockchain we made mention about, Bitcoin, literally works. Transaction is being made, it's sent and broadcasted to the chain, and then the miners add, the transaction is added to the block, and then the block is being added to the blockchain. So this is an example diagram of a blockchain transaction flow. Transaction is requested and authenticated. A block represents created transaction. The block is broadcasted in the network. Nodes validate the transaction. Then the node will receive rewards to validate the crypto, which we are going to talk about as time goes on. Then the block adds to the existing blockchain. Then updates will share across the network for distributed system. Then the transaction is complete. Imagine all of these flows going through like this. That's why it's not easy for transactions. So many transactions should be done at a time. That's one of the problems, the scalability issue. Future blockchain technology innovation increases security by reducing single point of failure, scalability solution. That's where we spoke about sharding. I've not mentioned sharding, but layer 2 solutions. I've made mention of layer 2 solutions. Then enhanced privacy features. Sharding is just, let me explain what sharding is. Sharding is just the ability for computer engineers, they must have come across the word sharding. It's just the ability to split work into simple chunks for the operations to be done easier and faster. So a big work will then be splitted into simpler chunks for it to handle it faster. So that's literally what sharding is, and on the high level of things. Then other things is enhanced privacy features using zero knowledge proofs. I'm sure I've mentioned zero knowledge proof. Then integration and emerging technologies. We have Internet of Things, AI. AI is so popular that so many people are integrating it in every single thing right now. So yes, this technology can also be integrated into the blockchain. Imagine you have all the devices in your house connected to a blockchain, and at any point you are in the world, you can literally just control your device since all the data is being stored on the blockchain. It's so easy and fast to just do that. So adoption trend, you hear increasing use in finance, supply chain, and healthcare. Then also growing interest in DeFi's and NFTs. We hear of regulatory development and standardization. So at this particular point, we have come to the end of everything that has to do with introduction and fundamental of blockchain. Now, here's the type of method I use for teaching. I ensure that every single person on the call is carried along. So for this very reason, I always pause at intervals to ask questions and to hear feedback. And also it's one of the reasons why I also ask questions myself, so that I could hear what everyone is thinking and what everyone is learning, if it is sticking. So at this very point, we have gotten to the junction where we want to ask questions and we want to discuss. So can I hear questions? And if there is no questions, you can give me a thumbs up. Rather, I'll then have questions from everyone. And I could just call your name randomly. I would just want you to unmute your mic so we can hear from you. Definitely, it's going to be something that would have motivated you to join the class. But before I do that, is there any question from anyone based on all the introduction to blockchain? Okay. Okay. Mark, Paul, and Ben, you have question. Let's start with Mark, Paul. Okay.
Sorry. Can I bring you back to the
Yeah.
transparency section?
Okay.
I still have a vague mental model on how the blockchain works. So when you say that, I remember you mentioned that people can actually view your credentials, and if you, let's say, you have performed a transaction, everybody has sort of like the receipts that, yo, this guy did pay this amount, for instance, to a restaurant. Does that mean they can actually see like your entire balance as well? Let's say if you're in the Ethereum blockchain and you possess the currency for that said blockchain, are they able to see your balance on top of your account and stuff?
Excellent question. So I would use a demonstration to answer your question. But let me hear what Ben's question is before I proceed. So, or let me answer Mark Paul's question. And then okay, Ben, let's just hear your question.
Okay, no, I just wanted to know where can we find these videos? Because I'd like to rewatch some of the videos, like the first one I never watched.
All of the videos are being posted on the Notion page, and all of these slides are also posted on the Notion page. You will get the link to the Notion page. I've sent it to this store before. I'll send it to the coding class. Can you mute your mic, Ben? It's giving a feedback.
Okay.
Okay, thanks. I'll send the Notion link, although I have not uploaded yesterday's class to YouTube, to the official channel, but I'll upload yesterday's class and today's class today. And after I'm done uploading it, that would be added to the Notion page and you can get access to it basically. So yeah, you have access to the recordings. Now going back to Mark Paul, let me ask you a question, Mark Paul. Were you in Monday and Tuesday's class?
Yes, I was. I was actually on the 21st, the class that was on the 21st. And my internet was a bit shaky at the time. So there's some parts that I definitely missed out on. But I did some reading, but that's the thing that I still can't get around. So I was hoping you could help me with explaining it.
Good. So remember I made mention that the blockchain is transparent, and you made mention of, for example, Ethereum. So for this example, I'm going to show you Ethereum, and I'm also going to show you the Stellar scan. So this is an example of what it looks like for the chain. Now, this is a scan. A scan is literally an outlet that literally gives you access to what is going on the blockchain. Now, for example, this right here is the latest block on the Ethereum blockchain. And inside of this block, you have transactions that has happened in this chain. This block contains all the can you see here transactions? We have 30 transactions that has happened in this blockchain. Can you see it? Now, if you click on the 30 transaction, here are everything that happened in the transaction. Everyone can see it. So now, remember that I said the transactions are always hashed, the blocks are always hashed. So this is the hash of this particular block, as you can see. This is the block height or the block number and the hash. Let me click more. So this is the hash of the block. And remember I was talking about the parent hash. That's the parent hash is the previous hash, as I was showing you from that example. Here it is. Here's the previous hash. Now let's go into the 36 transactions. Now inside of these 36 transactions, I'm going to click on one of the transactions. This is the hash of this particular transaction. So every transaction is hashed. Now remember, that is how important hashing is in the blockchain. So now for this transaction, what happened in this transaction? We saw that the transaction happened 1 minute ago. You can see January 22, 2025, 5:53 UTC. You can convert this to your own time. So it literally happened some minutes ago. What happened for this transaction? This person with this address made a transaction and sent Ethereum, that's Ether, I mean. He sent Ether to this person's address. So can you see how much the person sent? He sent 0.2218 Ether. And the person paid a fee of 0.00022 for the fee. Can you see? This is transparency. Now, we are now like, okay, can we see the account of this person? Can we see the balance of this person? Yes. So you can click on this, and it takes you right to the person's balance. Here's the person's balance. The person have about 347.126 on worth of Ether. And the total value of the Ether he has is about 1,140,000. So this person, that is how much he has. So you can also see the different other tokens. These are ERC20 tokens, and it also includes ERC721 tokens. If he has, you can see everything. So these are the tokens the person have, and the token this person has about $73,000 worth of tokens. Yeah. Now inside of this person's address, you can literally see all the previous transactions he has made. This was the one that led us here. The last one he did, and then here are other ones that the person has done. So you can view all transactions and start seeing all the previous transactions that the person has done. Can you see? This is why it is transparent and everyone can literally see it. So does that answer your question, Mark?
Yes, it does. Thank you so much.
Yeah, you're welcome. So, Lloyd, can we hear you? Your hands were raised, was raised. Okay. At the absence of questions, so I made mention at the beginning of this class that we are going to have a form of test every week. So I would send the link to the test between today and tomorrow. And take note, your scores in this test will definitely be recorded, as at the end of this quarter and semester, each participant that has above an average score that is required will be issued an NFT certificate to show that they actually participated in this cohort. And trust me, you really want to have that certificate to show. And it's not just having the certificate. Don't do it for the certificate. Do it to acquire the knowledge to actually use in the industry. But notwithstanding, also for the hackathon, we made mention that to be happening at the end. I want to also make it clear that those that have below certain participation, because it would be viewed as participation marks, might not be opportune to join the hackathon to win the prizes for whatever they are building. So it's important to do these assignments and, attend the classes. So it's going to be in form of a Google form, and I'll drop it in the class Discord between tonight and tomorrow morning, and the form would definitely close at the end of tomorrow. So by tomorrow night, the form will close, and then the marks will be recorded for those who participated in it. So
So
thank you
please,
very much.
which of the channels will the form be posted on?
The coding class channel, there's a coding class channel
Okay,
on
okay.
Discord. Yes, that's where it will be posted on. Someone else was raising his hand up earlier. Okay, yeah.
Yes. Uh, sorry, I also have another question. I would
Okay.
like to understand if we have the way to integrate with the current banking system once someone wants to withdraw money from blockchain technology. Is that possible? If you have shown us someone account on blockchain, and if someone wants to withdraw those money, and is it possible
Yes.
when we talk about
Yes.
cross-border transaction?
Yes, it is. Now, this is one of the things Stellar itself focuses on. It's focused on cross-chain transaction. That is, Stellar, you can literally integrate MoneyGram to Stellar for you to do some cross-border of transaction. Apart from that, that's just one method of thing. You can also send your cryptocurrencies to a centralized exchange for you to go through P2P. Or better still, you can convert your cryptocurrency to stable tokens and literally convert them to fiat on different other platforms. So it's easy. You can convert your money to fiat. Yeah. Sunday Solomon, your answer up.
Okay, I just wanted to know if it was still valid for me to talk about the transparency thing I wanted to say.
Oh, it's great to hear that you are now in a better condition, but the class is over. The class has actually come to an end. But I really do appreciate that, yes, you participated. And I really appreciate every single person that participated in the class. It gives me joy to understand that so many people are, participating in the class and they are getting educated on this. So, Biodun, do you have one thing to say before we end the class here?
Yes, thank you, Wayo. Okay, my it's not a question, but I sent a mail because I've not been getting the lesson notes or the link to the YouTube or the where we can channel to have all the recording because I've never missed any class in study. I've not been
Okay,
getting it.
you would get
So I
you
just
would
sent the
you
mail.
would get the link to the Notion page. You will get the link to the Notion page. I'll post it on the class channel. Thank you.
All right,
Last,
thanks.
Emmanuel.
Yeah, thank you. I missed yesterday's class and today's class. Just entered now. Is there not like a calendar or for
There is
schedules of classes? I, I,
all
I,
of
I can't find it in my mail.
oh um my name is Ayo on the group. So you would see me actively replying to messages. So if you have any problem like that, you can
Yeah, I'm,
literally reach
I'm not
out
in
to me.
any group, please. Which group should I join?
You are not on the official Discord of Stella.
I'm there, but I can't find the one. You said there will be a channel for us. What's
Yes,
the
there
name?
is a channel, the coding class channel. There is a channel. It is under, let me check this. Okay, I just saw your mail now. You sent a mail, Piotr.
Okay, thank you.
Okay. So it is under ambassadors. That's where the coding class is.
Oh, okay. All right. Thank you.
Yes, yes, yes. Okay. So I'll be ending the recording here. I'll stop recording.